Welcome to this explainer. Today, we're going to completely demystify the native bi-directional REST integration between ServiceNow and Atlassian Jira. Our primary focus today is crystal clear narration, breaking down what might seem like a daunting technical hurdle into a straightforward, step-by-step blueprint that you can easily implement in your own environments. Let's get right into it.
Okay, let's dive into this. Why do we even need to connect these two systems? Well, in most organizations, there's this fundamental divide. ServiceNow is the undisputed master of ITSM. It owns the incident, problem, and change management processes. But on the other side of the fence, Jira absolutely rules sprint-based software development. It's managing user stories, epics, and bugs. So when a ServiceNow incident requires a code fix, that work has to move over to Jira. Relying on manual copy-pasting between your ITSM teams and engineering isn't just a major headache. It's literally a massive source of data lag and human error. We need these systems talking to each other directly.
So here's our architectural roadmap. 1. Architecture patterns. 2. Prerequisites and off. 3. Outbound from ServiceNow to Jira. 4. Inbound back to ServiceNow. And 5. Mapping and launch. It might sound complex, but I promise you we're going to build it in a highly modular way.
Phase 1. Architecture patterns. Finding the right bridge between systems. Before we look at any syntax or write a single line of code, you really got to ask yourself which integration pattern is actually right for your environment. Think of this like choosing the foundation for a house, right? If you pick the wrong architecture up front, based on your security constraints or your team's skill set, everything you build on top of it is going to sag. You've essentially got three main paths. You have the native ServiceNow to Jira outbound REST, the Jira to ServiceNow inbound REST, and the marketplace integration hub spoke. Now, while using a pre-built spoke is definitely faster for admins who don't want to code, it comes with extra licensing costs. Today, we're going to focus purely on the native REST patterns. Why? Because mastering this teaches you the underlying mechanics of how these platforms actually communicate, giving you full control over your logic with absolutely zero extra middleware cost.
Phase 2. Prerequisites and auth. Laying the groundwork for a secure connection.
Look, you can't build a bridge without site access. You'll need admin or delegated developer roles in ServiceNow and Jira admin rights to generate an API token. But here's the kicker. It is absolutely critical that you create dedicated, non-personal integration users. I'm talking about actual service accounts on both platforms. If you tie this integration to your personal admin account, the entire bridge will instantly collapse the day you change passwords or leave the company. Seriously, don't skip that step.
Now, what's really interesting here is how modern ServiceNow development handles security, using a connection and credential alias. Gone are the days of hard-coding API tokens and passwords directly inside REST message records where any admin can just snoop and see them. An alias securely stores your Jira base URL and your basic auth credentials completely separate from your script logic. This means you can seamlessly swap between dev, test, and production URLs without ever having to touch your underlying code. A real game changer.
Phase 3. Outbound from ServiceNow to Jira, pushing tickets to engineering. Let's take a breath here, because this marks the beginning of our first major technical build, the outbound bridge. Building the outbound data push follows a very clean, logical 5-step sequence. Ready? First, we activate our required web services and REST plugins. Second, we configure that secure credential alias we just talked about. Third, we build the actual REST message record to define our endpoints. Fourth, we wrap that message in a reusable script include. And finally, fifth, we set up a trigger, like a business rule, to actually fire the process when an incident is escalated.
Step 3 involves defining your core HTTP methods. We use specific REST verbs for specific actions. You've got post to create an issue, put to update one, and get to retrieve data. For Jira Cloud specifically, you have to ensure your HTTP headers for content type and accept are explicitly set to application/JSON, or Jira is just going to reject your payload outright.
So the crucial point is this. As a developer, you should never, ever call a REST message directly from a business role. Actually, scratch that. Nobody should. Instead, we create a script include. Let's just call it Jira Integration Utils. This acts as a reusable, highly testable logic layer. It takes your incident data, dynamically maps it to the REST message variables, executes the call, and importantly, handles the HTTP response codes. This keeps your system architecture completely clean and maintainable.
For that final outbound step, the trigger, you've got a choice. Option A is a business rule, which is fantastic for script-first teams because the data flow is very explicit. Option B is Flow Designer, which is ideal for low-code environments. Honestly, I highly recommend that newer developers learn the business rule pattern first. Writing the script out forces you to understand exactly how the payload is constructed, which makes debugging significantly easier before you transition over to the abstraction of Flow Designer.
Phase 4. Inbound from Jira to ServiceNow. Catching the returning data. Now that we've built the outbound connection and pushed our data over the fence, let's look at the return path. How does ServiceNow actually know when the Jira developers are done?
To catch that returning data, we utilize a scripted REST API. By definition, this is a custom endpoint we expose inside ServiceNow. It essentially just sits there and actively listens. When an engineer in Jira updates a status or adds a comment, Jira fires a webhook across the internet. That webhook hits our scripted REST API at near light speed, which then automatically updates the original ServiceNow incident.
Setting up this reverse direction requires just 4 steps. First, we create the scripted REST API record. Next, we add a post resource, maybe we call it /update, and write the script that parses the incoming JSON. Third, we secure it. And fourth, we jump over into Jira system settings to configure the webhook that'll target our new ServiceNow URL. You want to carefully select only the issue updated events here, so we don't accidentally spam our own instance.
Let me be incredibly clear here, especially for the sake of clear narration and secure systems. This scripted REST API URL is exposed to the outside internet. Locking it down properly is absolutely non-negotiable. You must check requires authentication equals true. You must create a dedicated inbound integration user with the absolute bare minimum roles needed. Please do not give this inbound account full admin rights. Whether you use basic auth or OAuth 2.0, enforce strict security and optionally utilize IP allow listing to ensure only Atlassian servers can talk to your endpoint.
Phase 5, Mapping and Launch. Rules of the road for a successful sync.
We've got the plumbing connected in both directions, but now for the data translation. You have to agree on this mapping with your Jira admin counterpart. Let me explain exactly how this works. For example, to map Jira's incoming string-based status.name, like done or in progress, back to ServiceNow's numeric state field, you can't just copy the data over and expect it to magically work. You need translation logic for the data types to match flawlessly.
And this brilliantly illustrates the status mapping pattern. Instead of hard-coding endless if-else statements in your scripts for every possible Jira status, you build a simple custom lookup table. This allows you to map Jira statuses to ServiceNow states via standard records. It's a massive win because it empowers business analysts and non-developers to easily maintain and update these mappings in the future without ever having to touch or risk breaking your core integration code.
Before we launch, we follow a strict test sequence. Don't rush this. Unit test your REST message first. Then test your script include in the background. Then, and only then, do an end-to-end test. Make sure you also do negative testing. Temporarily revoke your Jira token and verify that your script gracefully logs an error rather than just failing silently. Oh, and during volume testing, always keep an eye on Jira's per-minute API rate limits.
Let's move to our final step and see how this builds our final sign-off checklist. Before moving from your sub-production environment into production, verify everything. Plugins are active, service accounts are locked in, your script includes safely wraps your REST calls. Inbound auth is strictly enforced. Your lookup tables are populated, and your system logging is actively tracking all successes and errors.
So, I leave you with this question. Is your instance truly ready for seamless DevOps collaboration? By replacing manual tickets with a robust, automated bi-directional bridge, you aren't just saving time, you are fundamentally elevating how your ITSM and engineering teams work together. Take this blueprint, apply it to your environment, and start building. Thanks for joining me on this explainer.